So in this video, we're going to start shifting, talking about just the basic laws to now applying those laws. And the first thing we need to really talk about is diagramming forces, but also problem solving, of which one of the steps, in fact, step one, is diagramming these forces. Okay, so it's not uncommon for multiple forces to be acting on an object. I forgot the S there. So if this happens, then you need to find the net force, which is the vector sum of the individual forces. And the first step is to draw what we call as a free body diagram. So a free body diagram is just a simple picture. You don't have to do anything crazy, right? I'm either going to draw a box or a dot. In fact, on the AP test, they're going to give you one of those two, the box or the dot, and you have to draw the forces that are acting on the object. Now, you do have to be careful, because if you have forces at an angle, if you're on an inclined plane, not to draw the components. You're only going to draw those forces that they're asking you, or that you know is acting on the object. The components, yes, are acting on the object, but they are not the force that is acting. It is the total force that is acting on the object. Okay? So once you have all the forces drawn, then you can choose a coordinate system which will help you resolving forces into components. So at this point in time, Newton's second law will be applied separately in each direction. Okay, and so we talk about the problem solving. So the problem solving comes down to 3 steps. First thing is draw the free body diagram. Okay, so draw your free body diagram. Second thing is to sum the forces, which we've kind of did when we were doing the Three Stooges problem, when I was finding F net, and then I'm going to set that either equal to ma or 0. Okay, if the object is not accelerating, right, I'm going to set it equal to 0. But if the object is accelerated, I'm going to set that equal to m times a, and then I'm going to solve for what I'm looking for. Now here's how this works. The draw and the sum step, that is physics. Okay, that's us doing physics, right? Drawing the free body diagram. And the reason why it's physics is because we have to identify forces and put those on a picture. The summing, well, it's Newton's second law, which is an application of physics. Solving is algebra. And it's not even difficult algebra. It's basic systems of equations. I have something on this side I need to bring over onto this side so that I can solve my problem. So here's just this quick little example. So I've got these 2 astronauts that are pushing on a satellite. One is pushing, astronaut 1, as you can see, his force is going to the right. Astronaut 2 is pushing up. And so I'm going to replace the satellite with either a box or a dot. Doesn't matter which one you use. And so I'm going to say, okay, F2 up, F1 to the right. So this right here would be my free body diagram. And then I can go and find the net force. So if it's asking me for what is the net force that is acting, well, it's going to be the force, it's going to be pushed up in that way. Okay, so this would be my F net. And so I have 2 sides of a right triangle, F1 and F2. How do I find the third side of a right triangle? Well, Pythagorean Theorem. So the net force acting on the object will be the square root of your x forces squared plus the square root of your y forces squared. Okay, so that's just like a basic type question, but we're going to talk about other questions where we're not necessarily finding the overall net force, but what we're finding is the acceleration in the x direction, acceleration in the y direction, the frictional force. So we're going to apply these. Now, note that because this is a vector, this will give you the magnitude. The direction is given by the inverse tangent function of your net y over your net x. Okay, so let's look at an example talking about now applying numbers to these astronauts, but we're going to go through the process. Okay, so draw. first thing we do is draw a free body diagram. So there's my satellite. Again, I got 2 is pushing up, 1 is pushing to the right. And this is actually just asking me for what is the magnitude and direction. So there's no real summing, but we can say, okay, I like to do a t-chart. So I would say F net y is equal to m, right? And so this would say like MAY, F net x is equal to MAX. So you can solve this a couple ways, but there's only one force, right? In the x direction, there's one force in the y direction. So there's my sum step. And now my solve step is to, one, figure out what the x force is, right? Or I can find the x acceleration, right? Then I can find the y acceleration. Okay, and then I can do Pythagorean theorem, or I can find the net force by doing the square root of f1x, or f1 squared plus f2 squared. All right, so it's going to be the square root of 46 squared plus 56 squared. And so that's going to give me a net force of 72.5 newtons. And then I can find the acceleration by doing F net over m, so 72.5 newtons divided by 940 kilograms. And that's going to give me an acceleration of 0.0771 meters per second. So you can see it's not a big acceleration. Now I need to find the direction by doing the inverse tangent of my y, which is 46, and my x, which is 56. And we're going to find that this satellite will accelerate at 0.0771 meters per second, and the angle would be 39.1 degrees. Okay. One thing to note is that that's also the direction of the net force, right? Because acceleration and net force go together. Okay. So now from here on out, you have the basic problem solving, and everything that we're going to do from here on out is applications of our problem solving. So draw, sum, solve. Draw the free body diagram, sum the forces in each direction, and then solve for what you're looking for.